And a very good morning to one and all. I'm Mahendran Reddy, Head of Ecosystem of the National Additive Manufacturing Innovation Cluster, NAMIC. Today, it's my utmost pleasure to welcome everyone to the NAMIC Virtual Summit 2021, Innovating for Built Environment with Construction 3D Printing. Today marks the 10th edition of our Summit series, a very remarkable milestone, and we definitely won't be here today without all our valued collaborators and speakers who have been great pillars of support in our events. So our greatest appreciation goes to all of you. Since 2017, our Global AM Summit series has featured more than 150 global thought leaders who have made significant contributions in the field of additive manufacturing in their respective industries. With the success of the virtual installment of Global AM Summit in 2020, NAMIC has expanded this into a series of key virtual events across the year. Each virtual summit would focus on the status of AM advancement globally in different industries, with today's spotlight on the built environment. In the recent months, we have seen significant progress in how AM is innovating for and disrupting the traditional construction industry. In the US alone, 3D printed houses have begun to be listed for public sale, and the demand has exceeded the current supply that construction 3D printing companies can actually provide. So why 3D print houses, you may ask? Now, I'll leave that question to be answered by our speakers, who are all industry experts in their field. So let's take a look at our agenda for today and to see what we have in store for all of you. First up, we have Dr. Chaw, the Managing Director of NAMIC, who will kick off the summit with his welcome address, following which we would welcome our keynote speaker, Mr. Kelvin Wong, Chief Executive of the Building and Construction Authority of Singapore. Next up, we have Mr. Jordy, Team Leader, Digital Construction of Witteveen+Bos, Mr. Willy, founder of Hamilton Labs, Mr. Sam Ruben, Chief Sustainability Officer and co-founder of Mighty Buildings, and finally, Mr. Jörg, Petri, Business Development Manager of BASF Forward AM. To round up the session, we'll be holding a 45 minutes panel discussion and question and answer session where you can ask our speakers some questions in the question and answer box below. You can input your questions at any time today throughout the webinar, so do send in those burning questions and we will try to answer them. Moderating this session will be Mr. Richard Hassell, co-founding director of WOHA, an internationally acclaimed architectural practice right here from Singapore. Richard leads project teams in design, execution, and contract implementation of innovative private and institutional works. All projects in WOHA are conceptualized out of jointly developed schemes and strategies. And on top of his experience at WOHA, Richard has also served as a board member of Design Singapore Council, the Board of Architects, as well as the Building and Construction Authority of Singapore. Richard, I've said a lot about you. Would you like to say a few words to our audience, please?
Really, I'm excited to see what's coming up. I saw in the introductory videos a lot of the topics that intrigued me. I think about formwork manufacture and developing standards. As a practitioner, this is like a kind of toy box that I can't wait to get my hands on. But so far, it's always just slightly out of reach. And I feel like we're at the moment where maybe that paradigm is shifting, and we'll start to be able to use these amazing technologies and production methods. So I can't wait to hear it, Mahendran, and I'll be back at the end to share some questions from the audience and from myself too, I'm sure. Okay.
Absolutely. Thank you, Richard. We are really looking forward to that panel discussion later and really getting everybody on board this journey that we have embarked on. All right, it is now my greatest pleasure to invite Dr. Chaw, the Managing Director of NAMIC, to kick off our event with his welcome address. NAMIC is a Singapore government platform initiative to catalyze innovation and scale industrial adoption of digital additive manufacturing technologies. Since its inception in late 2015, NAMIC has raised several millions in public-private funding to support various AM initiatives across several industry sectors. Before joining the public sector, Chaw had spent several years with HP Singapore and Chartered Semiconductor, where he undertook various executive roles in technology product development, as well as business and supply chain operations. An advocate for 3D printing and the role of technology for the betterment of humanity, Chaw has a passion for nurturing deep tech startups and has spoken at numerous forums. So without further ado, Chaw, over to you, please.
Thank you, Mahendran. Very good morning, good afternoon, and good evening to everyone from wherever you are. Very warm welcome again to all of you who have made time to attend this Built Environment Summit on 3D printing. We're deeply honored today to have with us 5 very distinguished speakers from the global built environment community to share with us their perspectives on deploying digital fabrication technologies with a focus on 3D printing to improve our construction sector. I'm also deeply honored to have invited Mr. Kelvin Wong, CEO of the Build and Construction Authority Singapore, to kick off a summit today. Lynn, can you move to the next slide? So the construction sector is one of the largest in the world economy, contributing 13% to the global gross domestic product, which translates to about 10 trillion spent on construction-related goods and services every year. However, the industry's productivity has trailed that of other sectors for decades. Globally, construction sector labor productivity growth has averaged about 1% a year over the past 2 decades, lagging the productivity growth at 2.8% for the total world economy and 3.6% for manufacturing. Absent change, global need for infrastructure and housing will be hard to meet. If construction productivity were to catch up with the total economy, the industry's value added could rise by $1.6 trillion a year, and that would meet about half of the world's annual infrastructure needs, or boost global GDP by 2%. While there are barriers to higher productivity, ways of overcoming them have been known for some time. Most companies, just like any in other industry sectors, generally lack both the incentives and the skill to change. However, there are forces that are lowering the barriers for change, such as rising requirements, increased demand in terms of volume, cost, and quality, disruptive new entrants, more readily available new technologies such as prefabrication or precast technology, new materials, as well as automated processes such as concrete 3D printing, and of course, increasing cost of labor with partial restrictions on the migrant workers. Next slide. So one of the solutions for the industry is to move toward an automated manufacturing production system that would boost productivity up to 10 times, potentially. So construction or concrete 3D printing has progressed rapidly in the last few years. And you can see on this slide that we just took snapshots from almost every other country that we can find. And you can see that several new entrants have actually entered the market with their own technology that's catering to this construction 3D printing. Construction 3D printing offers the following. It facilitates greater off-site manufacturing, vastly reducing on-site construction. It enables modularization and standardization of construction processes. And most importantly, it requires less workforce in a more controlled and safer factory environment. In Singapore specifically, I think efforts have been underway in the last few years to explore the adoption of this technology as part of the digital transformation that is now rapidly changing the landscape for most of our major industry sectors. On this note, I just want to thank again all our distinguished speakers today for being here with us to share their insights on the pathway towards adoption of construction 3D printing technology. I'd like to wish all of you a very fruitful and productive session. Thank you very much. Back to you, Mahendran.
Thanks much, Chaw. Thank you very much. Next up, it's my pleasure to introduce our keynote speaker for today, Mr. Kelvin Wong, CEO of the Building and Construction Authority of Singapore. Prior to joining BCA, Kelvin was the Executive Vice President of the Singapore Economic Development Board, EDB. At EDB, Kelvin oversaw the development of strategic growth engines in hub services and supply chain and connectivity, as well as the board's new businesses and policy and planning divisions. He started his career with EDB in 1996 and has helmed various key portfolios, including logistics, professional services, and urban solutions. He has also served on the board of Singapore's Employment and Employability Institute, E2I, and is also the alternate board member of the Human Capital Leadership Institute. Without further ado, let's give a warm welcome to Mr. Kelvin Wong to set the stage with his presentation on shaping the future of Singapore's urban landscape. Kelvin, please.
Thank you, Mahendran. Hi, morning and afternoon and evening, everybody. No, first, let me thank the NAMIC team for inviting me to kind of kick off this virtual summit. Don't think I can, I was just sharing earlier on that amongst everybody, I'm probably the least informed about this space. But anyway, earlier this month, I had the opportunity to visit the NAMIC 3D printing lab in NTU. Actually, I found the visit to be very, very insightful, and actually to gain insights on the different types of technologies and materials on this whole additive manufacturing space that could potentially support our urban development. And I'm actually glad that even as we continue to observe safe distancing measures, I'm glad that technology has enabled us to actually allow us to gather virtually now. I'll just touch on a very quick points. I think 2020 will always be remembered as the year where COVID really forced businesses to transform. I think it's quite common for us to hear about how COVID has forced many different businesses to actually adopt digitalization much faster than they have ever done in the last 10 years. And I think likewise, the built environment is kind of under the same kind of pressure. So in Singapore, our built environment had a tough time last year, especially during the circuit breaker, when we had to cease almost all work. Projects could not really restart as the outbreak in foreign worker dormitories had to be addressed first. And even now, the firms are still operating at a lower capacity due to safe management measures on site. And to get through the worst of the pandemic, we had to intervene in an unprecedented way along the whole value chain. We injected a significant support measure, a total of 1.36 billion Singapore dollars, to actually help the industry defray the additional compliance costs as a result of all the COVID safe measures that they have to put in place to resume work safely. But even as we keep an eye on the pandemic, I think the crisis has highlighted a number of key weaknesses as well as opportunities for our industry. I think the key themes that BCA will be stepping up our efforts on will be digitalization, productivity, and sustainability. And I think many of you who are based in Singapore would know that actually for a number of years now, we have pushed quite a bit on DFMA, Design for Manufacturing Assembly, and IDD, Integrated Delivery, Digital Delivery. And on both fronts, I think we have made decent progress. And today, Singapore, we have, in terms of DFMA, PVVC adoption is actually quite at a high level. And in fact, Singapore is home to some of the tallest PVVC buildings in the world, residential buildings in the world. On the additive manufacturing front, I think our colleagues at the HDB Center, the Housing Development Board Center for Building Research, together with Robin Village Development, Witteveen+Bos, and NTU, began their journey with a research project to explore the adoption of 3D concrete printing. HDB has since developed the largest 3D concrete printer in Southeast Asia with the capability of manufacturing building components of various sizes. I understand that the center has prototyped about a 10 square meter room size 3D printed volumetric component with reinforcements all within 13 hours. And further research is ongoing to determine the structural integrity of 3D printed concrete components over a longer period of time and suitability to our local climate. In addition, a partnership between NTU as well as Sembcorp Design and Construction and Sembcorp Architects and Engineers produced a 3D bathroom unit, printed bathroom unit, within the day before finishing it with sanitary fittings. The findings from this project were promising, with potential 30% improvement in productivity and 30% lighter than conventional prefab bathroom units. And this has garnered interest among the main contractors, and presently, the 3D printed PBU project is owned by the Chip Seng Corporation after taking over Sembcorp with the intent of mass production. They could be first, hopefully they'll be the first 3D printed PBUs to be granted in principle approval for use in local projects. So just based on gross floor area, it is understandable why the two use cases so far are in high-rise buildings, because Singapore is an urban, densely built city. It is also possible that in that segment, in the high-rise segment, DFMA platforms such as PVVC or advanced precast systems are leading the charge. But in my earlier discussion with Chaw and Mahendran, we spoke about how 3D printing could be very interesting for the low-rise landed property segment here in Singapore, where each and every project is highly customized and not well suited for precast systems. So given that many of these use cases overseas have actually been in the low-rise buildings, I thought this should be an area that we could look into more deeply as well in Singapore, given that we also have a productivity challenge in that segment. So what can BCA bring to the table to help grow the 3D printing segment here in Singapore? BCA's mandate, as many of you may or may not know, our mandate is both being an industry developer as well as a regulator. So as the BCA team work with the industry to drive initiatives in digitalization, productivity, and sustainability, I think that could be a role for BCA to help convene and connect between possible use cases and the community that's gathered around here today. We are interested to identify the solutions that are likely to work in our context and that could help transform our sector. The second thing that I think we can do is that as the lead agency overseeing building safety in Singapore, we want to be pro-business and to be an innovative regulator. This would demand us to be at the cutting edge of many innovations such as 3D printing, and where needed, look at how regulations could facilitate the use of technologies that can help advance our sector. So I was quite keen to hear from Sam in the snippets earlier on about how in the US, some of the codes have been are being developed. And I think this is something that I think we ought to take a look into as well. To these two ends, I think my team and I will be discussing more with NAMIC on how we can do this, and also looking to hear more ideas from everyone in this community. So while the pandemic has presented significant challenges to the built environment sector here, I believe it has also given us the collective impetus and commitment to transform and emerge stronger. So BCA will be doubling down on all our efforts to bring about this transformation that will include supporting capability and technology development, and that will make Singapore ready for the future. So I look forward to forging and strengthening new and existing partnerships with participants from the seminar today to shape and transform our B sector here. Thank you.
Thank you, Mr. Wong. Kelvin, that was very insightful and really very heartwarming to see the great support that BCA is actually putting behind these efforts that NAMIC and the rest of the industry are all on this journey for industrializing 3D printing for the built environment. So now that we understand a little bit about the environment and its landscape a little bit better, let us dive deep into the 3D printing scene in the construction space with our speakers. First up, we have Mr. Jordy, Team Leader, Digital Construction at engineering consultancy firm Witteveen+Bos. He's based in Singapore, where his team is focusing on the digitalization and automation of the architecture, engineering, and construction industry. The technology of 3D concrete printing is one of their key focus areas with their BIM to manufacturing workflow. It's one of their main value propositions. A notable mention is that Jordy was involved as a consultant in the development of 3D concrete printing technology, as you heard, with the HDB, the Housing Development Board in Singapore. So let's hear from Jordy what he has to share with us. Hey, Jordy, all set?
Hey, hello. Thanks for the introduction, Mahendran. Let me share my screen so everyone can see my presentation. All right. So I will tell you more about how we can reinvent sustainable housing by making use of smart manufacturing. Before we jump into that, first a quick introduction about me and the company I'm working. So I'm working for Witteveen+Bos. It's an engineering and consultancy firm with over 1,300 colleagues. And we have a turnover of about 150 million euro. And on a yearly basis, we complete about 4,000 projects in the field of infrastructure, water, environment, and construction. Our headquarters is in the Netherlands, and we have offices in 11 more countries. And as Mahendran explained, I'm based in the Singapore office. In the Singapore office, I'm working together with a team which we call the digital construction team on digitalization and automation of the construction industry. And we have a whole range of, let's say, services to help doing that, ranging from consultancy to design and engineering, development of technologies and implementation of technologies. So I will not go too deep into that, but one of our key technologies, as Mahendran mentioned, is 3D concrete printing. So why do we need these smart manufacturing technologies in construction like 3D concrete printing? It was already mentioned in the introduction, so I will not spend too much time on it, but we have in the built environment and in the construction industry certain challenges. Think about, for example, the productivity is very low compared to other industries. Also, the safety is really something we need to improve. There are fatal accidents in the construction industry worldwide. And also the industry is responsible for a large part of the CO2 emissions, which is even 11% of the worldwide emissions for just the building materials. And if you take into account even the operational phase of the buildings, it's almost up to 40%. And besides that, there is an increasing need for housing worldwide, and also an increased densely populated cities. So we need to create more healthy cities where it's pleasant for everyone to live. And 3D concrete printing is a great solution because it can help to solve many of these challenges. It's an automated construction method with a high amount of productivity. There's less human involvement needed. That helps greatly to increase safety. It is a technology that is making use of the material in a very efficient way, and therefore it's a sustainable construction technology. And also, we don't need formwork, for example, and that allows us to create more freeform shapes and create more pleasant and appealing cities for everyone to live in. So let me give you a quick introduction how 3D concrete printing works for the ones who have not seen the technology before yet. So first of all, 3D concrete printing is a robotized technology. It's basically a robot that is moving a printhead, and it can be all kinds of robot actually. So I will show later on some examples of that. So this printhead is extruding concrete that is coming from a mixing pump, and it's building up a concrete object layer by layer. And this is all controlled by a robot controller, and the robot controller receives input from the digital designs that we as engineering firm are creating. So we have created a full digital workflow from these digital designs of the buildings, all the way up to something that these robotic systems can read. And if you do that in the correct way, it looks something like this. You know, we can print complex shaped objects layer by layer, hollow structures in a fully automated way. So why is 3D concrete printing sustainable and smart? Well, let's have a look at the traditional way of doing construction. We are looking here at a typical workflow to construct, for example, a concrete wall. And this is even a more simplified version of it, but just to give you a bit of an idea, there are a lot of different steps to come from this design to a finished product. And all those steps require a lot of manual work, a lot of what I call analog work. It's not digital. And moreover, it's also done by a lot of different people who all have a different skill set to do these steps. So summarized, it's a very segregated process with a lot of failure cost in between because the processes don't connect well to each other. And also because all those steps are still very manual, it's labor intensive and human friendly. And because we make use of, for example, formwork, we have a lot of material waste. So if you look at the 3D concrete printing process, it's a very smart way of doing manufacturing because it's a way more, let's say, simplified and integrated and connected process, where we go way faster from design to the actual manufacturing processes with way less manual and analog steps in between. So this is what you can imagine of the future of 3D concrete printing, where we have 3D concrete printing systems that don't only do the printing, but do also all the additional steps that are needed to come to that end product. Think about the placement of reinforcement, surface finishing, painting, tiling, and so on. And that process is fully integrated, which helps greatly to increase the productivity. It's automated, which helps to create a more human-friendly way of doing construction, and it's very sustainable because there's barely any material waste. And because we don't need formwork, we have way more design freedom, and it helps to create healthier cities. So let's zoom in a little bit more on the manufacturing of housing. What are the benefits of 3D concrete printing for housing? I will go through 4 benefits. If you know more benefits, feel free to drop them in the chat. So first of all, like I just mentioned, it's a highly automated way of doing manufacturing. So this helps a lot to produce houses faster, with less labor and less raw materials needed, with all the advantages that I just mentioned. But it can also help a lot to create lightweight building components, as you can see here on the screen, which again helps to reduce materials. And this is really needed to create those cities, to help accommodate for that increased housing need worldwide. But there's more. Also because 3D concrete printing has this great design freedom, it helps a lot to create shapes or houses or buildings that blend in better in green and natural environments, to avoid that we get just pure concrete cities. And that is for everyone a more pleasant environment to live in. Here you can see on the left side one of our revisions, how 3D concrete printing can be applied in high-rise buildings. And on the right side, you see a hotel in Singapore, which is not produced with 3D concrete printing, but if you look closely, it actually looks like it is 3D printed. So 3D concrete printing can also really be used as an architectural feature in designs of buildings. Besides that, 3D concrete printing is really a great method for the design freedom. We don't need that formwork that you really need to repeat to earn it back. And that gives us the possibility to create tailor-made houses. I think that mainly works on the lower rise one-off buildings. But this really helps for everyone to, express their creativity and create that one house that they would love to live in. Tomorrow is our press release for the Milestone House in the Netherlands, where the first house is being constructed, and that will be a house where really someone can live. So it's an approved load-bearing structure, for example. And also houses on demand, because we have this very efficient workflow from design to manufacturing. We can create houses when they are needed, instead of first waiting 6 or 12 months before the design is finished and construction can start. So this really helps to create, for example, those one-off landed houses that are needed in many parts of the world as well. So how does the future look like? As was mentioned in the introduction of this event, a lot is happening around the world. So you see that the technology is being adopted more and more worldwide. And you saw my image on the introduction where you see that 3D concrete printing is happening all over the world right now. You see on the bottom, for example, the example in Singapore of the 3D printed prefabricated units. And on top, you see, for example, our 3D printed bridge in the Netherlands. So for those projects, we have done the design and engineering. But there are way more applications ranging from just building components all the way up to fully 3D printed houses and everything in between. Besides that, you see that the equipment that is being used for 3D printing is becoming bigger and bigger. So this massive frame that you basically see here in this photo is actually a 3D concrete printer. You also see that the machinery becomes more and more advanced, more and more integrated, different processes that are all connected to each other. And you see that specific type of robotics are being developed purely for 3D concrete printing. You also see that the pilot projects are getting bigger, and you see more of them happening all over the world right now. So I think that line will continue, and to make it more mainstream, that is also really needed. So I often get the question, is 3D concrete printing the future of construction? And will we see on every construction site in the future a 3D printer? Well, I definitely think it is the future, but I think it will exist besides existing construction methods, like, for example, prefabrication. Also, prefabrication is being highly digitized nowadays, and it really depends on the needs of the project, which technology suits the best, just like that happens in any other manufacturing industry. And they can even be combined. So it can be that certain parts are prefabricated, certain parts are 3D printed. And that fits very well in the way construction is being transformed right now into a more industrialized factory type of manufacturing. Besides that, the technology will also become cheaper over time. This is something that we have seen in other 3D printing industries. Everything besides construction, basically, where first of all, the cost of the 3D printers and the 3D printing processes become more affordable over time. And on top of that, the speed, the productivity of these technologies are increasing. And it has also something to do with, the more a technology is being deployed, the more competition will be created in the market, which helps to reduce the prices. And because of that, demand is increasing. So it's a kind of endless cycle that really helps to make the technology more affordable. Besides that, there is a strong relationship between the material, the printing process, and the designs. And to create safe structures of high quality, we need to standardize this relationship and understand what happens if we use this material with this type of process and this design. So all of that is being standardized, and that's also one of the components that is highly needed. And we need to find the right applications on the short term and on the long term of 3D concrete printing. So in which projects and in which applications is 3D concrete printing, of course, feasible, desirable, and also viable. And here we need to look for opportunities where 3D concrete printing, where the advantages of 3D concrete printing are at the right place. And even when 3D concrete printing on the short term might be more expensive, those added values can offset that additional cost, and you can do something that, for example, cannot be done with traditional construction methods. And that is where the biggest opportunities are for the short term. So this is the end of the presentation. I would like to end the presentation with this photo. And let's all embrace robotics for the construction industry and make the construction industry a more healthier place for everyone. Thank you for your attention.
Jordy, really amazing. I can see that you're clinging on to this whole area of technology that you and Witteveen+Bos is pushing. And I really wish you a lot of success in the areas that you are really developing this very well. And very inspiring as well to see the progress that you're making, in this 3D concrete space. So congrats and keep going. Now sharing his knowledge with us, we have Mr. Willy. He's the founder of Hamilton Labs, a division of Hamilton's Holdings Private Limited, which focuses on 3D printing in the built environment. With Hamilton Labs, Willy kickstarted an initiative in India to 3D print concrete toilet units and cubicles, aimed at improving sanitation standards for the masses. During the pandemic, the company had diversified further into multidisciplined 3D printing in the built environment by exploring other 3D printing materials such as metals and high-performance composites, and additionally secured design and build work streams in India for G+1 houses. With his passion for improving lives in the built environment sector by tapping on 3D printing technology, Willy is very excited to share with us the benefits that this tech can bring to the construction industry. So Willy, the stage is all yours. Welcome on board, sir.
Hi, thank you. First of all, I want to thank NAMIC for this opportunity. And I also want to thank NAMIC for picking this topic for me, which is what I've been looking at since I started 3D printing. Let me put the screen. Okay, is it on the screen?
Yeah, we can see it clearly. Okay. Thanks, Willy.
Okay, so again, like I was saying, thank you, NAMIC, for this opportunity. And after hearing what Jordy presented, I also want to thank him for laying the groundwork for my presentation next. It is a precondition to what I'm about to embark to discuss. Building and construction is caught in a time loop. Jordy talked about robotics and digitalization, but various components in building and construction are still caught in the olden ways of doing things. And I believe in pictures speak thousands of words. So it highlights the difficulties that 3D CP is facing, and the challenges ahead. Building and construction, from the very beginning, the methodologies and the technology, the methodologies hasn't changed much. I wanted to use the Woolworth building and the Burj Khalifa as an illustration, because the foundation of building and construction hasn't really changed much in the last 100 years. And if you go back further, a lot of methodologies hasn't changed. So with all the talk about Industry 4.0 and how we are going to digitalize the construction industry, I think 3DP and industrial additive manufacturing will play a leading role in bringing the construction industry to Industry 4.0. And again, to highlight the topic, actualizing affordable construction using 3D printing, I can't help but have to mention Fordism. Fordism was founded by Henry Ford way back in the early 1900s. What he pioneered was he pioneered the modern model of mass production in the auto industry. When I was in school, many years ago, I always remember this. My professor said, what Henry Ford, how he sold his cars is, you can have any color you like as long as it's black. So that highlight the deep standardization of his product. Now, standardization of a product means you can mass produce such that at a price so low that a common man can afford, and I think to actualize affordable construction, this Fordism is something that we need to that can play a role in the consideration. And again, another effect of Fordism is the use of special purpose tools and or equipment via the assembly line. Again, Jordy earlier talked about robotics, showed pictures of large scale 3D concrete 3D printers. That is part and parcel of the special purpose tools. Now, again, the most important of Fordism is the elimination of labor in direct production, while at the same time promoting skilled labor and the corresponding rewards. What Fordism was about is to increase affordability by reskilling labor such that they earn more money to be able to pay for the cars that he built. So it brings me to the next topic, which is digitalization and digital fabrication. Now, first of all, we talk about labor. Construction, at the end of the day, is very labor intensive. Somehow the industry accepts that building and construction can continue to be labor intensive. Hence, the adoption of 3D CP has been slow. Productivity, as Dr. Ho mentioned, has been lagging behind other industries. So I see, in order to actualize affordable construction, we need to reorganize and digitalize labor. By doing this, we remove a certain level of the value chain that labor plays in the building and construction industry. At the same time, digitalization also leads to labor upskill and reskill. It's by reskilling and upskilling, it it improves affordability, because as the way of living, the standard of living increases with new skills. Now, digitalization also leads to work stream adaptability. With digitalization, everything starts in the virtual world. Now, with digitalization also, it's an efficient communications and information flow. In this time and age, for just look at what we are going through right now. This is digitalization in its essence. We're holding a conference with enough participants, virtually. Now, at the same time, digitalization also increases design flexibility, which in the brief video I mentioned, the 3D printing in construction, the technology and the methodologies are already very mature, as Jordy demonstrated. So what is essential is the design flexibility. I firmly believe that with digitalization, design is the major role in pushing forward 3D CP, and further to make sure that construction is affordable. Now, to define affordability, housing is considered affordable when rent or mortgage plus utilities is more than 30% of a household's gross income. So affordability becomes very relative. People who can afford a Rolls Royce obviously has different purposes. So by upskilling and reskilling, we improve the affordability of housing, and henceforth more affordability towards the buyers. I think this part, not just again, I have to thank Jordy. We went through this part with zero material waste, with waste savings, and again I fall back on design, because precise design, material, and resource management leads to better cost control. And the most important thing is design can start in the virtual world. Now, 3DP also enhances innovative and sustainable designs and technologies. We with 3D printing and digitalization, we can make sure we can improve designs to improve the productivity of each component. And with improved designs, there are cost savings, all the good things with 3D CP, faster construction. You already mentioned earlier geometric freedom and sustainability. Then we talk about the delivery system. The toys that we deploy along the production system is naturally the 3D printers. Now, 3D printers come in various forms, as Jordy presented earlier. You have the robotic arms, which provide more flexibility, and I used to say, the robotic arms can be made to do the most complicated Pilates positions. So it improves the production system. Then you have the concrete 3D printers, which is the gantry 3D printers, which makes standardization easier because it behaves exactly like a production line. So there is potential for cost savings from additive manufacturing when machining, molding, casting, and tooling are not required. So I think the delivery system, the printer, is a powerful tool and equipment as part of the assembly line. And again, we go back to design, which I think Mr. Wong talked about earlier, which is design for manufacturing and assembly. Earlier on, I talk about the FAM, which is design for additive manufacturing. So again, I fall back on the fact that design is critical. With digitalization and integrating offsite assembly line processes with in situ building and construction methodologies, 3D-CP exemplifies everything. It begins in a virtual world. It begins in the minds of architects and designers, and that smart factories and advanced manufacturing run the world. At the end of the day, I think there will be factories which are 3D printing building components and then put together on site. Now the emergence of BIM, the building information modeling, has brought the building and construction industry forward. But again, BIM basically hasn't been adopted in full yet, and I see BIM playing a big role with 3D-CP, with the manufacturing line, and improving the realization of actualizing affordable construction. Now 3D-CP also provides a green reboot on the circular economy, because we are able to reuse certain materials. For example, molds can be crushed to be reused. Now, one big factor here is it attracts new talent and build up required skills. Again, I go back to this slide where affordability is defined with new skills and new talent. It builds up affordability, because with improvement in income, the affordability goes up. Now, 3D-CP is also, it's also highlights the importance it's important to integrate and collaborate across the construction industry's value chain. I think it cannot stand alone. That's why we over the last 14 months, the pandemic, we Hamilton Holdings, we explored different materials like Mahendra mentioned. We go into the metals, which we are looking at 3D printing facades and molds to cast the facades. So the whole value chain has to be integrated. And with integration comes further standardization, which then it's the realization of affordability can happen. Now everything has to be scalable. That's where the standardization comes in. It's important to be able to standardize product. I mean, again, I've mentioned what Henry Ford said: you can have any color you like, as long as it's black. That's how costs come down with standardization. And I'm not talking about bespoke houses. I'm not talking about building bungalows. I'm talking about affordable housing. Affordable housing essentially means a high level of standardization. So this is where the assembly line and standardization come in to make affordable construction work. Now, at the same time, I also want to talk about case in point, which Mr. Wong talked about as well, which is the PPVC, the prefabricated pre-finished volumetric construction, and the PBU, which is prefabricated bathroom unit. Now, again, this is a strong move towards standardization, because the public housing space in Singapore is all about standardization, and that's a strong move towards lowering costs, because again, this is from BCA. It improves productivity up to 40%, and this is the 3DCP is not even involved in this process yet. Better construction environment, because it's fabricated off-site, assembled in situ. Then of course with fabrication off-site, it improves the quality control. Now what this diagram is Hamilton Holdings' vision of how a production line of the case in point of PBUs and PPVC will look like, where it resembles a lot with an automobile production line, where robotics come in to do finishing work, where robotics come in to cure, where robotics come in to even do 3D printing, which is a very good possibility, and it's part and parcel of the finishing process of 3D printing. What's very important here also is again, every PBU and every PPVC essentially is standardized, because the market here that we are focusing on is again the public housing in Singapore. Now, even for some private housing, certain components in private housing is also standardized, which can also be part of this production process. I've put together a Hamilton Labs additive manufacturing and robotics hub, which is essentially a digital fabrication, assembly, and finishing line. Now, one of the things to consider that here is there are certain components in Singapore that can adopt this methodology, and a perfect, everybody talks about COVID-19. I think COVID-19 and the Suez Canal disruptions, they were perfect storms because they disrupted the value chain absolutely. And with a production system like this, it alleviates the risks of these disruptions. So this is the end of my presentations. I welcome any questions towards the end of this seminar. Thank you.
Willy, thanks so much. I can really sense your passion here. You've been in this business for quite some years, and I think there's more we can actually harvest from all of this passion that you have and to push the industry further. So next up, we have another highly driven thought leader who has loads to share with us, Mr. Sam Ruben from Mighty Buildings. Sam is the Chief Sustainability Officer and co-founder of the company, which uses 3D printing technology, new composite materials, and robotics to manufacture houses. His passion and deep understanding of sustainability and compliance drew him to the vision of addressing the housing affordability crisis by 3D printing sustainable homes. Now, this has resulted in Mighty Buildings producing the first UL-listed 3D printed building component, being the first company certified under UL 3401, a new standard for 3D printing in construction, and the first housing unit utilizing 3D printed components to be certified at the state level in California. I'm not going to steal your thunder, Sam, so let's hear it from you. Over to you, Sam.
First off, thank you so much. It's an honor to be on this panel with such illustrious fellow speakers, and really excited to share a bit with you about what we're doing at Mighty Buildings, and initially a bit more about kind of the key role that 3D printing can play in helping address the sustainability, the climate crisis that we're also facing along with the housing crisis. So let me just share my screen here. There we go. So one of the things that it's important to recognize is that we're really facing a dual crisis between housing and climate. Obviously, as I mentioned, there's a huge need for housing across the world. There's a study from the McKinsey, came out with a study a couple years ago indicating by 2025, so just 4 years from now, 1 in 3 urban dwellers will be impacted by housing scarcity. But at the same time, as it has been pointed out a couple times already tonight, construction plays a huge role in global warming and in the climate crisis. So how do we deal with this, address this fact, given that climate crisis is impacting our housing stock, both in terms of the flooding that you're seeing here, but also in terms of the fires and other issues, or even sea level rise. I was just reading today about here in the Bay Area in California, where many homeowners are being told they have to move and that their homes they paid millions of dollars for are going to be worthless because they cannot insure them, they cannot renovate them, they cannot work in them because they will be below sea level. And so this is something that's ongoing. And so even while we're seeing these impacts in terms of sea level rise and flooding and fires and more and bigger storms that are causing greater and greater devastation, we're seeing that this is impacting all of the housing in some communities. Foster City is just right down just south of where I am here in California, and almost 100% of their housing stock is exposed every single year to climate impacts, particularly from sea level rise and fire and other impacts, as mentioned. And at the same time, construction's 11% of all, accounts for 11% of all global warming emissions for the construction phase. Building energy use phase is another 28% of all global warming. And neither of those account for the carbon generated by the waste during the construction phase or at end of life. So the impacts of the built environment are even beyond what we're seeing here. And it's not getting better. And the simple fact is, at a time when we need to be shifting as much as we can and decarbonizing our building stock to get to zero carbon buildings, we're actually seeing that we're falling further and further behind than where we need to be. So what this really speaks to is the fact that we need a better way to build. And this is something that I feel we at Mighty Buildings and myself personally feel really strongly that 3D printing has a huge role to play. And that's why it's been so exciting just in the last 6 months even, or in the last year, to see what the new developments are coming onto the market, such as the multi-story building that was printed in Dubai, or what's been done in Germany, or what we've seen down in Tennessee with first 3D printed building facades that incorporate insulation, as well as what we're seeing here in California and Texas and New York in terms of bringing 3D printing into the residential market. And at the same time, as has been mentioned tonight, the regulatory environment is incredibly important. And the simple fact is that the building code exists because it's written in blood. I mean, these regulations are there because things went wrong and people got hurt and people died. And so it's incredibly important, as we're rushing to take advantage of the new opportunities 3D printing presents, that we're doing so in a way that demonstrates the safety, and that we're working to build out that regulatory structure and that standardization that can help building officials feel confident that a 3D print structure not only is going to be safe, but it's going to last for years and go above and beyond code. Well, as has been mentioned, there's been some great work with UL that we're particularly proud of in helping them develop their new UL 3401 standard, which is the world's first standard for the investigation of 3D printed building construction. There's also been the ICC acceptance criteria 509 for the use of 3D printed concrete, which was originally approved in 2019 from work with Contracrafting, and was recently updated for multi-story use cases in concert with Black Buffalo, which is another 3D printed concrete company out of New York. And additionally, UL has worked to actually get UL 3401 added as an adoptable appendix to the International Residential Code. So as of January 1st, 2022, when that goes into effect, municipalities and jurisdictions that base their code off of the International Residential Code will actually be able to take that adoptable appendix and plug it into their building codes to provide them guidance. And even those that don't formally adopt it will still be able to refer back to it. Additionally, efforts are underway by UL and others to continue this addition of 3D printing into the code by working to bring it in as an appendix for the International Building Code as well, to be able to expand it beyond just residential and really move into that commercial space. And so these standards are incredibly important, not only to ensure the safety of the structures, but also to help make sure that if someone doesn't follow them, and if something goes wrong, that doesn't set back the entire promise of the technology by decades, which is a very real possibility. And so here at Mighty Buildings, we're in Oakland, California, and our mission is to create beautiful, affordable, and sustainable homes using 3D printing, robotics, and automation. So we originally founded the company in 2017, where we started with a desktop printer with a curable composite 3D printed material that we developed. What you see there is that desktop. And then in 2018, having gone through Y Combinator, which is a relatively well-known tech accelerator here in the Bay Area, we were able to take that from a tabletop up to a container-sized printer from January to March. And then from March to November of 2018, we actually went from that container-based printing system to the largest light-based printing system in the world, which is our current Big G printer, which has a print volume of 11 feet by 26 feet by 13 feet. It's actually limited more by over-road transport than it is by the actual print size of the printing itself. In addition, along with the unique material that we've developed, which is a photocurable thermoset composite, so essentially a synthetic stone, we've also developed post-processing that continue further unlock the versatility and potential of this platform. So along with the ability to use the 3D printing to take the most difficult and dangerous parts of the job, here in America, the framing of houses is the second most dangerous job after mining. We're able to both mimic existing designs and aesthetics, as well as introduce curves and freeform design in ways that just hasn't been possible up until now, at least at an affordable way. Think Frank Gehry, like the Guggenheim Bilbao. We can go crazy, or we can make it look like the house next door. In addition to the printing, the robotic finishing cells that we have utilize KUKA arms that have been proven out in the automotive and aerospace industries to provide additional quality control as well as post-processing. So along with the ability to do a 3D scan of the physical object to make sure it matches the digital file it's based off of, it also creates a digital file of that physical object to create toolpaths for the fact, because one of the cool things about our material is that even though it's really strong, it's still soft enough that it can be treated with CNC heads that are normally used for coppers and aluminums and other metals. So what this means is that we can leave the raw print that some people really, really like and are willing to pay a lot of money to have done on using traditional materials. We can mill it so it's a smooth stone-like finish, or we can introduce whole new facade looks, as well as being able to make it look like brickwork or siding and mimic traditional aesthetics. So that's one of the things that we're very excited about, the potential of this technology to unlock that versatility. And then in 2019, we, as mentioned, we went through our certification process with UL and became the world's very first UL listed 3D printed building component. And then when 3401 was published, the first and thus far only company to be certified under that new standard. At the beginning of 2020, while we were still in our original Redwood City facility, where we were operating in 7,500 square feet in a shared warehouse, we also created our first fully printed shell of one of our Mighty Studios, which is the smallest of our product lines. And those units we have since been delivering here in California, both the single module and multiple module, which means we can actually install a house in a day. We actually just completed a delivery last week as a 2-module unit that was installed, welded, sealed, and inspected all in a single day, and move-in ready the next day. Moving forward, along with the ability to do volumetric modules, we've been working on a panelized kit system. For those who may know the history of housing in the United States, you may be familiar with the idea of the Sears kit homes from the 1920s and 30s, which were essentially flat-packed homes they would ship on rail and be ready to assemble on site, and many of which are still standing today and are a testament to the quality that can be achieved with a panelized system. We've taken that idea and incorporated 3D printing to take it to the next step. So with our 3D printed panels, we're not only able to provide the interior finish, the exterior finish, but everything in between. So your insulation, your thermal barrier, your air-water barriers, your vapor barriers, your fire barriers, and really provide something that can be assembled very quickly, but that can also be delivered to any backyard as long as you have a 6-foot opening. So it really opens up the possibilities, and it also makes it really easy to create custom floor plans for builders and developers, as well as setting the stage for where we're moving next year, which is in the ability to open up our technology for third-party designs, as well as to be able to step into low-rise multi-story. So initially 2 to 3-story townhouses and 3 to 6-story apartments that are so key to urban density here in the United States. And so what you're seeing here is the printing of that first prototype fully printed shell. And so again, this was in our old facility in Redwood City. We've now moved into a 79,000 square foot facility in Oakland, out of which we can generate 300 units a year, 360,000 square feet of production, and which we're upgrading our system to expand that to 1,000 units a year, or 1.2 million square feet of production out of that same 50,000 square feet of production floor. The other 29,000 are storage and office space. But so what you're seeing here is a single print cycle. We were actually able to print this entire shell in 24 hours. And so what you can see there is it's essentially a synthetic stone that's been printed using similar honeycomb patterns and cellular infill to what you've seen in others. But one of the advantages that we have over 3D printed concrete, at least in order to meet code here in the United States, is we don't have to stop and reinforce it. Because one of the things about 3D printing in the US, in order to qualify under the code, building codes, is you still have to reinforce it. You still have to pour additional concrete in here. So it's kind of robbing the 3D printed concrete of some of its promise because of those code requirements. And unfortunately, we in San Francisco and the Bay Area know particularly well what happens when you build with unreinforced concrete in seismic areas. It does not end well, hence why reinforcement is required. And so one of the things we're excited about with our new technology is that we're actually moving forward with the fiber reinforced version of our material that's going into certification. And what that does is actually creates the ability to have a similar size beam to a reinforced concrete beam, but have about 20 times better tensile strength, equal or 2 times better compressive strength, depending whether you're long or across the fiber, all while being 4 times less in weight, 4 times better in insulation. That's something that we're really excited about as we move into multi-story, is really that ability to eliminate the need for steel rebar and other materials and really focus on that decarbonization through dematerialization. And so, as has been spoken to by both Willy and Jordy, is that 3D printing also unlocks the potential for Industry 4.0 and these ideas of digital fabrication and all these buzzwords that are thrown around. But with the new technology that 3D printing provides, they're actually achievable. I mean, the simple fact is, as Willy did a great job of demonstrating, your file never has to leave the computer. I mean, here in the US, we have to print it out to get permits, but that's the only time. So that means that not only can you incorporate design changes late in the process, you also have the opportunity to do things like advanced simulation, which means that we can run a simulated build thousands of times before we ever get to that first prototype, saving new product introduction speeds by as much as 5 times faster, as much as 100 times less in terms of cost. Additionally, we're able to generate units with about 90% less labor hours per unit. But at the end of the day, the goal is to create more work and attract a new generation of workers because we're increasing productivity by as much as 20 times. And we're giving younger workers a chance to work with the latest in technology. Because here in California and the United States more broadly, we've seen a loss of all of our skilled labor. In 2008, when the housing market collapsed, most of your skilled general contractors left the industry. Those that stayed or came back tended to be older. They're now retiring and they're not being replaced. For every 5 skilled workers that are leaving, 1 lower skilled worker is entering. And as a result, even though we need millions of units of housing here immediately in California, we build roughly 100,000 a year. It's not even roughly 1/10 of what we actually need to be doing to get where we need to be going. And additionally, with 3D printing, as has been mentioned, you can print exactly what you need, which means that with a 3D printed house, we're able to eliminate over 95% of the waste that would be generated in a traditional stick build. And it also gives us the opportunity to do things like capture the powder from the milling process, incorporate that into new materials so that we're actually addressing that waste factor that's not even accounted for in most LCAs. And the other great things are the ability to integrate in-process quality control on a level and a scale that you just simply can't do with traditional builds, ensuring a much higher level of quality while still having that automated production line that can run 24 hours a day. And so these are just some of the projects that we've delivered so far. Here, all have been here in California. And initially, we've been focusing on the accessory dwelling unit market, which is a backyard granny flats. So little apartments go in the backyard. That's something that the state of California has made really easy to permit. And it made a great place for us to really step into the market, demonstrate the viability of what we're doing, but not be in competition with the builders and developers, designers who we've always seen as our end customers. So our goal at the end of the day is to be a tool for industry. We want to help unlock the productivity necessary to solve the housing crisis, while also addressing the climate impacts of that additional housing to make sure that we're not exacerbating the climate crisis. So one of our first steps into that is the new Polari Villas project, which we recently announced that'll be placed down in Rancho Mirage, down in the Coachella Valley here in Southern California. So this is the world's first zero net energy 3D printed community. So these homes are incredibly energy efficient, but also incorporate solar as well as battery backup to ensure that they're generating as much energy on site as they're using over the course of the entire year. So this means that we're reducing, on the production side, because of the avoided waste, we're able to save 1 to 3 tons of carbon, depending on whether we're in California or another state, since California has much stricter end-of-life recycling, has much stricter waste diversion requirements, and also saving about 400 kilograms of carbon a month from the energy being generated on site, and additionally providing savings of over $100 per month to your average California. So this is just the first of 5 planned communities with Polari Group, and we're also moving forward with developing a similar type of communities with other builders, which we're very excited to hopefully be able to announce in the coming months here. And so in terms of sustainability, one of the things that we're doing at Mighty Buildings, along with what like Willy spoke to about designing for additive building, is actually also what's it look like to design for assembly and manufacturability and assembly, as well as disassembly and reuse. And beyond that, we've also identified opportunities for end-of-life recyclability, initially through grinding up our material and reusing as filler, but looking forward, as we continue to adopt improved formulations, having the ability to actually create a truly circular material that can take advantage of some of the latest advances in chemical switching and depolymerization. So with our new formula that we're moving into certification right now, we're already seeing a 20% improvement over our previous formula and are well on our way to achieving our goal of carbon neutrality by 2028. And we're actually planning on going beyond that into regenerative practices by seeking to achieve carbon negativity by 2040. So we're really helping to drive the construction industry to embrace new tools, new ways of doing things, because the only way that we're going to continue to thrive as a species while building all the housing we need is if we're doing so in a way that minimizes or ideally even turns those houses into solutions for the climate crisis. So really excited for the panel discussion, your questions, and if you want to reach out to us, you can visit us at mightybuildings.com. You can also email me at sam@mightybuildings.com or just our info. Thank you so much.
Sam, that was very exciting. What you've been doing and how Mighty Buildings have been moving the needle in many ways, from material development to standards development. It's very, very exciting for us from this part of the world to see what's going on there. So we'd love to see you here at some point.
We're looking forward to it.
Yeah. So that would be really great. So to enrich our industry here. So congrats and keep it up, and we'll catch up with you soon in the panel discussion. And now for the final presentation for today, I'm pleased to invite Mr. Jörg Petri, Business Development Manager at BASF Forward AM. Speaking all the way from Germany, it's currently about 5:20 a.m. over there, and we really appreciate, Jörg, that you're here to speak with us. So thanks very much. BASF Forward AM develops sustainable product solutions for architecture and construction, enabling 3D printing. Jörg is a registered architect at AK Berlin, and through his years of activity with a focus on digital design and construction, he's well versed with the challenges for construction of the future. Before joining BASF 3D Printing Solutions, Jörg was co-founder of Now Lab and then Now Lab Innovation at the 3D printing startup BigRep. For 3 years, he researched and taught at the ITE of the TU Braunschweig in the field of robotics and additive manufacturing methods for construction and design space. Now, today, he will share on how 3D printing can open up new doors to sustainable design and construction solutions, creating new facade systems and revolutionizing concrete construction with 3D printing formwork. Jörg, all yours. The stage is for you. So, guten Morgen, welcome.
Yes, good morning. Thanks, Mahendran, for the nice intro, and thanks for the invite. I'm just going to share my slides. So I hope you can see this. Yeah, can you see the slides? Yeah. Okay, so yes, added value of architecture and construction through 3D printing. I'm architect and business development manager at BASF Forward AM. And I always like to start with this one, even though for sure in this round you know much about it, the maturity of 3D printing. So this is a study from 2018, looking at the different components in construction for 3D printing. We all know bridges. We have seen it today. Bridges have been addressed so far. So blue meaning the development has been done and it's basically growing and continuing to develop. And I think houses, what is, let's say, at least for Germany, also a big step. You probably have seen it, the first printed residential building in Germany published in the beginning of the year, but also the, let's say, certified building. So this is actually a big step, I think, for this technology to break through, that you can really offer it on the market. I think this is very important, especially in Germany, where you have a lot of, let's say, regulations. So for molds, it was meant that this is already fully developed. I can show a bit more later, so there's still room of improvement. For sure, architectural models, every architect knows it's a standard, let's say, technology we use. Interior design, I find it very difficult. There are a lot of one-offs. We also did a lot at NowLab, but let's say like really serial production or integrating it into interior design as more than one unique design, which really nice designs are possible, I've not seen yet. And the building components, which I will talk about more today, also is for me a very interesting topic, because it's not about printing the whole building. It's really seeing where are the, let's say, components within the building that make sense to be printed and can add value to architecture and to the construction. So looking at that, these are our large format AM solutions I will address today, from formwork through glass inserts and full facades. And I always talk about a digital craftsmanship. We have heard it also today, like really bringing back this craftsmanship idea on site, which actually, in my understanding, has vanished from the building sites because of costs and labor intensity and labor costs. And I see really a potential of this printing in combination with the design possibilities, parametric design possibilities, to bring this digital craftsmanship or this craftsmanship back on site. So 3D printing clearly enables you to realize your individual project. This is a concrete facade panel that we made, created through a mold that was 3D printed. So printing the formwork for your custom-made concrete facade, that's basically the idea. On the right-hand side, you see the mold. We're all familiar, and you can use this in exterior or interior. But for me, this important part here is that you really could see a shorter lead time through this coherent digital process chain that actually combines now the digital, let's say, planning processes with the production. This is very important. I mean, have been working at UN Studio, and they are using digital design already for quite some time, but now combining, and a lot of offices as well, but combining this now with fabrication, it really is the key. And when you then start to also address the material topics, trying to bring back, let's say, materials that are used back into the loop, like a circular economy idea, it really becomes powerful and it reduces waste. And yeah, so this is actually, I think, a very key visualization of the process chain. So from design, either scanning, simulating, or designing it new, printing it, creating the cast, and then reusing the material that's been used to make the cast. So these are first examples we have done in terms of surface quality. This more rough surface quality I find very interesting. It's a really unique thing coming from the technology, as we know, layer by layer, and also the smooth surfaces are for sure possible. This is a project from Saadid from 2011. Their 3D printing was not used. If we would do this today, this would probably be, the forms for that would be probably printed. And this gives me an intro to this form active idea of structures. So really using the geometry to enable a geometry that uses less material, less concrete, maybe not even reinforcement, because it's all pressure based. And then you can even serially make these unique parts. So for me, this is a very interesting part of making these form active structures, producing less concrete, therefore less CO2 emission. And that's really a perfect fit for 3D printing. If we look at this, we have created now together with the ATH team and a big team, this step, which is actually a form active step. And it saves up to 50% of weight due to the geometry. So this is actually a project we're going to realize next year. And with the fiber reinforced, ultra high performance fiber reinforced concrete stair, it's only one part of this unit. You see all the teams involved. It's a very nice co-creation project between different partners. And as mentioned already, so the geometry, it's not only like a really nice design, it's really a form active design which doesn't use classic reinforcement. Therefore, you can actually make these forms, and it reduces the weight of 50% compared to conventional staircase. So here you see the mold that we created, one of the bigger parts, just to get an idea of the scale and also the complexity. So this can, I would say, only be done with 3D printing. Using other technologies here, like milling, to do these complex forms, it creates a lot of, let's say, effort to turn them around and work on them on different angles. And that's why 3D printing here really makes sense to create this unique structure. Just a short fast forward of the printer working on this, and a sneak peek on the first step. So we will show more images and for sure soon. So this is the first step that got casted lately. It's very fresh image, so we will provide you with more information on this. So really enabling this digital craftsmanship, this is for me a key for 3D printing to be established on site and to enable these unique structures we actually need in order to be sustainable in the future. So behind these really nice images, there's really this engineering solutions that we offer here at BASF for DM. So we can create the molds from any geometry. We do partly structural analysis, and we also do scanning of parts. So basically we can also work in reconstruction, replacing, let's say, existing parts, fitting in like inserts into a facade. Also again here with different surface qualities, we've scanned like a embossed stone detail of a building. And for sure, as an outlook, we want to go also more on the large scale on-site structures. And this image really shows, it's a project from Mart architects in China, that this really craftsmanship for sure is very nice, but on the other hand, also not affordable everywhere. And it creates, it's a lot of time to do this. And for sure, we want to make this process more easy with ready-made forms that can actually then be more effective and productive on site. These are the key takeaways. I will just jump through them quickly because we will do the recording, so I don't have to go in detail. So the glass inserts as a second topic, really nice. We work with WOHA Looks together on this. It's a new way of guiding light and do sun shading. So basically, it's an insert within the glass unit, within the insulation glass unit. And actually now through 3D printing, you can individualize this. So the function is still the same. And the outcome basically on the right-hand side, you see it here behind glass. It's a sun shading device, but it also spreads the light due to the translucency of this material, but also guides the light in additionally. Here also again a nice detailed shot of the print. And what you can now do is actually increase the dispersing the light in the room, increasing the light intensity by guiding the light into several areas into your space, but then also combining it with individual designs. So effective daylight usage combined with this unique design process. This is how, let's say, an example glass element looks like, that you then just build in as a standard glass into your facade. And it's protected within this glass, which makes it really nice. It's fireproof for high rise. It can be used in any location. So this is actually a product we have now established. You can use it to embed your logos. Also, we have a more reflective surface invented or coating that we can use, a metal coating that actually increases even the reflectivity. And for sure, you can now fine tune your design according to the let's say, situation in your space. If you imagine a shop in the entrance, you can have privacy zones where you have more denser design structures, and you have a public space where you want to show and where you want to have people looking in. So it's really individually possible to design this. And also in the evening, when you light it from the inside or from the side, it really creates very nice effects. So yeah, this product is available it can be built into your project. Basically, I'm quite happy that this is being developed now. And the third I want to address today is really printing facades directly. We call it fluid morphology. So we work together here with 3F Studio, which is a spin-off from the TU Munich. And basically they have invented this idea, fluid morphology, from research now to getting towards product level. Responsible for the design and planning, and we as part of BASF 4DM develop the material and produce the facade panels and enable the durability and quality of this product. So the key thing about this facade is really that it's one element, and this makes it much easier in the end later to recycle it, to bring it back again into the circular loop. So not assembling, let's say, 10 different elements from a facade that we normally know, but really having it in one element. So you could say it's like a low-tech solution for a multifunctional facade. And also here again, the process of producing and planning is combined, coming closer. You reduce communication errors between the planning partners by directly printing what you're planning and what you're anyway already designing in 3D. And you deliver it on site prefabricated. So here the key, let's say, aspects, as I said, which are integrated in this facade. So also sun shading for sure, the visual connection, acoustics, structurally it's optimized within. You have the insulation already, let's say, as part of the component, and for sure ventilation. So this is a visual impression of how these panels look like. It's really changing a lot in the reflectiveness depending on how the light comes through. This is, for example, an interior view. So also you experience this facade from the inside as from the outside. And it's constantly changing for sure through the weather conditions and also through the light that you put on. And why do we have this geometry? Why do we have these waves? So every project location is specific. Every facade in the end is unique. This is possible through parametric design now. So you really locate your building and calculate the facade according to the sun angles that will hit the building. So 3F has done some solar radiation analysis, let's say a flat facade compared to this wavy facade, and actually you see the blue areas which indicate that there's less energy impact onto the surface. So this is actually the reason why these big waves are there. It's kind of like an integrated sun shading brise-soleil, which is basically part of the whole facade. And this is only possible through now the parametric design and the computational design, and then also bringing these elements together, jointing them in a proper way, but still having this individual design cannot be done feasible with any other technology. We have went through the certification process for one project. So basically you see the structural testing, we did the fire certification, and also building up the serial production that enables actually repeatability of the quality that you need. Yeah, and also here again, the key takeaways for you later in the video to study more in detail. Thanks a lot. So this from my side, and I'm looking forward for the discussion today. And yeah, thanks for your attention.
All right, Jörg, thank you so much. It's very early in the morning, but a lot of great content and great work that's going on at BASF AM 4 AM. So now we are down to our final and interactive portion of the summit. And now it's my pleasure to invite all our speakers back on stage for this live panel discussion. We've already received a lot of your questions, which we will answer shortly, and use these to seed more discussion amongst the speakers as well. Now, it's my pleasure to hand over the stage to the man of the hour, our moderator, architect, Richard Hassell, to finally take over the stage. Richard, the stage is all yours.
Thanks, Mahendran. And thank you to all the speakers. That was a pretty amazing series of very short but very informative presentations, which has got my mind reeling. We do have quite a lot of questions. Some of them have been answered. And so I'll just select some. I guess we just had George speak. So one question we've had is, how far is the development of plastic 3D printing and construction? Are you planning to develop new materials?
Yes, so as you've seen just now what I presented, so these are the, let's say, products that are on the way, that are also already established or possible to be put into your building and to design with. So for sure, it's a constant process. I mean, the requirements, as we know, on site and for a long livability in the building is quite strong in architecture, and this is actually the key challenge, to really find the materials and for sure trying to use the ones that are already there. But if there's specific need, we for sure go into the development of looking more in detail and fine-tuning. So it's a constant process for sure. With the facade, as you could see, we're still in development also of the material. But for formworks, for inserts, it's already possible and has been developed. Yeah, so we are definitely continuously adapting the material with the application. This is really key, and I would say that counts for everyone. I mean, everything that we've seen today is in the process, and you can constantly optimize.
Actually, I was curious that last, the fluid, what was it called? The fluid morphology facade. That one is still a plastic based, is it? It's not a glass based product.
Yes, it's a plastic based. It's actually a PET based facade. This is the material solution we have now. So recyclability is guaranteed. It's really guaranteed, let's see, at least from the material source as we know it. And for sure, we're now testing long-term stability of what does it mean if this facade is exposed to the outside, and what can you do afterwards when the facade has been on there for some time.
Okay, so for Singapore, it'll be a little bit of a challenge, as our fire department here is extremely conservative with plastic-based materials. So maybe something, Mahendran, that we can work with Kelvin and other agencies to try and get the fire department at least involved in test bedding some of these things and making sure they could be approved here, because it does look extremely exciting to have that all the functions of the facade, done in one material. It's a very beautiful expression of its functions, and in a very aesthetic and attractive way. Okay, maybe something for Sam from Mighty Buildings. How important are regulations and standards when it comes to AM adoption? And what is the importance of creating space for different types of technology?
Yeah, so as I spoke to, it's incredibly important that we have effective regulatory structure and effective standardization for additive manufacturing in order to demonstrate the safety of what we're doing. Because building officials are understandably somewhat conservative in many places, and there's good reason for that. And so by moving forward on that standardization and the regulatory structure, it provides a framework for people to understand what is a safely done 3D printed structure. And it allows us in the industry to have guidelines that we can design to and that we can work towards. And also, and as I alluded to in my presentation, it's also really important because if something goes wrong, we need to be able to say, okay, well, this is why they didn't follow X or Y, or is it like, or whatever the cause was, to make sure that it's not setting back the entire technology, regardless of the material and the type, from the promise that it holds as being such a big part of our solutions. And that also speaks to why we need these regulations and these standards to be done in a way that's as broad as possible in terms of what materials can be done and what what processes. And that's because we're seeing a lot of innovation in a lot of different spaces. I mean, just look at this panel. I mean, look at the different ways we're all approaching the same problems with completely different technologies and completely different materials. But we all need to be able to demonstrate that we're meeting the same safety standards and the same requirements. And so by starting with something that's broad and that it kind of provides an outline, which is what UL has done with 3401, you can then take advantage of existing standards within the different, because there's amazing standards that already exist for concrete. There's great standards that exist for composites. And you can take those and then apply them as makes sense for that specific use case and that specific technology. I mean, that's one of the things we're doing, because along with the work with UL, I also chair the ASTM F420707 subcommittee on the application of 3D printing in construction. And that's one of the things that we're really looking at, as well as the ASTM ISO Joint Group 80, that's similarly working on applications of additive, is how do we make sure we're creating standards in a way that provides space for metal, for concrete, for composites, for these different technologies and materials that are already used in construction. We're just seeking to use them in new ways. And so really make sure to keep that space. Sorry, it's getting late here. I may be rambling.
Very useful. And Sam, like in terms of, because I think quite often innovation is running ahead of regulation. And so was that part of your business plan to sort of actively try and grow the regulation together with your technology side by side?
Yeah, that's been a key part of how we approach things, because of the nature of how heavily regulated the construction industry is. And because of the novel nature of what we were doing, we recognized early on that it was going to be very, very important that we're bringing the regulators along with us and making them as comfortable as possible every step of the way. And so even when we were in stealth mode, from the very beginning, we engaged with UL. We started meeting with local building officials in the communities where we were starting to get customers and really make sure that as we were continuing to develop out our technology, that we're doing so in a way that not only spoke to the pain points that we saw, but that the pain points that they have. And so a lot of that is being humble and showing up and being like, hey, I just want to tell you about this cool tech we're working on and to hear your thoughts. And making clear that at the end of the day, we're trying to make their lives easier and we're trying to do everything by the book. And so that's been a big part of our success and why we've been able to achieve what we have, particularly at the state level here in California and with the work with UL and moving in the codes is by really approaching it with humility. And with the recognition that these codes exist for reasons and that we need to make sure we're following them, but that there has to be a pathway to demonstrating that.
And it seems quite incredible to me because often codes are very slow. In my experience, they only may go through revisions. You are able to get it moving fast enough, the process, to be able to have your business delivering product, without waiting for several, 4 or 5 years to get it approved.
And so that's part of that is understanding the code itself and what opportunities are already there. And part of that is that my background, I have a dual MBA, MPA, so public as well as business administration, with a focus on sustainable management. So part of my studies and my work has been to know what does it look like to be on the public side of it and to look at things from their viewpoint. And I'm also a policy wonk, so I like reading the code. I'm one of those weird people. But one of the cool things about the building code is that there's an alternative means and methods section, which essentially says that you can do whatever you want as long as the building official says you can. And so that's where building out these standards and the work, and that's also where working with UL, and the reason we chose UL instead of the International Code Council or some of these other big names in the building space, is that not only does UL Underwriters Laboratories have over 100 years of building life safety, they also have some of the world's leading experts in additive manufacturing. So they were really uniquely situated to understand the technology and then understand what does it look like to demonstrate that code compliance, to allow us to have an evaluation report pretty quickly that demonstrated that we met code and allowed us to operate under the alternative means and methods section while we've continued this work to get 3D printing into the code itself.
That, maybe it'd be interesting to hear from Jordy and Willy as to the local experience with that. Like, how friendly are the local codes towards additive manufactured components or techniques?
Yeah, maybe I can add something to this. As Sam mentioned, there is no specific code yet for 3D concrete printing, for example, that can be used at this particular moment in time. But the question is as well, why can we not use the existing codes? What is the gap and how do we fill up that gap? So that is something that we are working on very heavily, for example, also in Europe. And until the moment that there is a standard for that, we apply what we call design assisted by testing. So usually you just have a standard or a code that says, well, if you do it in this way, and if you calculate it in this way, then it is safe. So what the authorities do is they check, oh, did you calculate it in this way? Did you prove it in this way? Fine, you can go ahead. So what we do instead, until that standard is there, we do our design and engineering, and we do structural testing to prove that whatever we have calculated, whatever we have done, is sound and safe and in line with what our calculations show. So that is the step in between. And that step in between will later on also serve as a very important base for the standards that are being developed. Because in that way we can show like, okay, we have calculated in that way and we have tested it in that way, and those things match. So if we do this in the future in exactly the same way, it will be the same as then. But we also investigate which things actually make a difference. I design it in this way, I engineer it in this way, I produce it, and it's not in line. Why is that? And that is, for example, because we 3D print things in layers. And that is something new compared to traditional construction. Our codes are made for a solid piece of concrete, for example, that has the same strength in all 3 directions. And now all of a sudden we have layers. So we need to be aware that those layers are there and that those layers have an influence on the final strength. That's something that current code does not say, but we know it. So we are aware of it, and that's why we do the additional testing. So yeah, I think, I don't know if that answers your question, but that's how we deal with it in the short term. And we work closely with the regulators to make that evolve into standards. Well.
And Willy, what's your experience been of?
The biggest hurdle we face in Singapore is always the building code, and I think it's not just in Singapore; it's everywhere. And I think this question, it's better addressed to Mr. Wong, because the buck stops there in terms of the building code. And I remember when I started this in 2017, the BCA was the first party we talked to about the building code, and understandably, the building codes around the world have been around for years and years and years and years. And again, I don't mean to generalize, but I sort of have the feeling during my earlier endeavors in 3DCP is if it's not broken, why fix it? So I think it's time. Now is the time to rethink. Again, to 3D print multi-story buildings. I don't see that coming anytime soon. But like in India, for example, we're working on a G+1 standalone house. Which we are working with a local architect in Singapore, and we're trying to push the envelope. We take it in small steps. I mean, 3DCP. My experience is I can't rush it. It's very frustrating if you start to rush it. So building code is one of the to me is my biggest, hugest challenge for 3DCP to be into mainstream building and construction. But before that, we just take one step at a time, and make sure the information we gather is shared, between authorities, and hopefully, the differences between the various building code standards around the world, can come to a consensus, and we take it from there.
Yeah. I mean, one thing Sam's presentation made me think of was countries like the US or Australia, where I'm from. They have a lot of kind of bottom-up possibilities because there's a lot of empty land, there's people with backyards, there's a kind of tinkering space. Where Singapore is particularly challenging is most projects are very large, they're very complicated because they're high-rise and close to the neighbors. And so that innovation space is tied up with a lot of risk in terms of, you know, projects might be $200 million, $500 million with a lot of time pressures and things. So I was wondering from Sam's point of view, like if you had to do a...
Maybe Richard, if you don't mind, let me just chime in here since, you know, keeping silence kind of makes it feel that I'm kind of the elephant in the room. No, I think, no, I think just say that, you know, I totally recognize in terms of how regulations and regulators can help in this space. I mean, really inspired by my previous journey where we were able to bring alternative proteins to Singapore. And I think Singapore could be one of the first nations in the world whereby we are now allowing the introduction of cell-cultured alternative proteins into the market. So I think similarly, I do feel that in this space of 3D construction printing is something that we could look into. You know, we'd be happy to learn from the likes of Sam, Jörg, and Jordy, and Willy as well. In terms of, I mean, even 3D construction printing is a relatively large space. And there are many things that you can do with 3D construction printing. And I think, you know, I actually have my chief regulator in the audience listening to this as well. We'll be very keen to follow up with, you know, some of the key leaders here to really understand some of the lessons that are learned in other countries and what we can replicate here in Singapore. Because like I mentioned earlier on, you know, when I kind of just spoke a little bit, was that I do feel that there are, you know, many areas that 3D construction printing could be very impactful in, but we need to understand that further. And then I think Sam shared a lot of very interesting examples that I thought was really quite interesting.
No, I was wondering, like, if Sam was told, do a startup in Singapore, given the high-rise environment, how would you start off actually introducing the technology?
For a truly high-rise, I'd honestly probably start with a combination of a light gauge steel frame and 3D printed components to create volumetric modules, utilizing the 3D printing for the facade and as much of the insulation and air, water, fire barrier as possible. But for the structural loads and particularly the connection points, at least initially, probably leveraging, so combining it with steel framing, which is actually kind of similar to what we're doing with our initial units here, where it's 3D printed components and a steel frame, again, to make it as easy as possible at every step for building officials to say yes, while we continue to build out the certifications and the connection technology necessary for those larger structures and to be able to eliminate steel in the future.
Yeah, okay, because yeah, I think that's the way it has been going in Singapore with PPVC, so components that are assembled together into larger elements.
But I will say that is one of the really cool things about 3D printed construction. It's already been shown across technology. It plays really well with traditional materials. So I think there's really interesting potential for hybrid approaches to really leverage the best of all worlds and really optimize designs. And that's for 3D printing to be not necessarily the tool, but a tool, but one that really unlocks a lot of other possibilities in ways that other materials and tools can't.
If I may add to that, I think Sam is completely right that 3D printing is a tool. We don't have to 3D print everything, right? We can combine 3D printing with existing materials and existing technologies, and the hybrid 3D printing is a great example of that. And it doesn't even mean that if we do hybrid 3D printing, it's manual. We can still cast concrete or place reinforcement with the same robotics that we use for 3D printing. So there is a lot of opportunity as well on the short term on doing this hybrid 3D printing. So yeah.
I mean, one thing I wanted to say, I'm a client. I've got a project which this intrigues me. At the moment in Singapore, can I get a competitive tender for something like this? Or it would be the case of having to develop a custom system with a negotiated contract in order to use the technology?
Sorry, can you repeat one more time your question?
I guess it would depend on which technology you're talking about.
Yeah. No, well, I mean, because as a practicing architect, this is what I always get attacked on, like from clients when you know, when you want to use something innovative, they're going, but how will I get a competitive price?
Okay.
You know, are there more than one in the market? What if that guy goes out of business, or you know, has another job and he's too slow? So I was just sort of curious with maybe Jordy or Willy in terms of is there enough players in the market for that, or it's still at a stage where you really need to partner with a specialist and do it as a negotiated contract?
I think it's getting there. There are quite some initiatives in Singapore, and not every detail can be mentioned here, but it will get there. But if you look across the border, you see that there are commercial, what they call printing factories. For example, in the Netherlands, there are 2, let's say, really factories set up that purely do 3D concrete printing, and there are many startups around it that also do 3D concrete printing. So there is a kind of competitive market over there for 3D concrete printing, and I think that will also emerge in Singapore. And besides that, if the project is big enough, something can be set up also for a project specifically, of course.
I think with any building and construction project in Singapore, I think we talked about this before. The architect plays a big role, and what we need architects because clients believe in the architect, and the architect, you know, for vanity's sake, is always looking for the next icon. And I think, you know, the architect together with the engineers and the 3D printing, you know, practitioners, we need to get together and start to we talked about this. The first one is always the toughest. And after that, so basically someone has to take the plunge. And I'm happy in Singapore that HDB is actually taking the lead. And sometimes, you know, with HDB, they can get, if they want, they can get very insisting. So we need something like that. But otherwise, I think the first plunge is tough. In Singapore, I thought of getting a factory space big enough so that I can attempt to 3D print a 2-story house. Not to sell, of course, but just to prove a point, and collect data for a building code adjustment. I wouldn't even call it change, but you know, for all we need is that the building code take a look at it and collect the data. So I think, you know, like Jordy says, we will get there. It's just quite an uphill battle.
So maybe I'll just jump in here a bit. Richard, could you just look at some of the questions directly? I think our audiences have some direct questions. Perhaps we just should look at them and answer those.
Yes, I think there's a few which are sort of about technical.
Should lump it together, yeah.
Which we can maybe talk about. For instance, bathrooms. Can we produce watertight walls? Maybe a bit relating to the like the structural comment from Jordy about the layered approach. Another one about the specific heat capacity of 3D concrete. So technically, maybe George, would you be best to answer in terms of I guess performance of traditional materials that are assembled in an additive way? Is there much difference in performance between the two?
Mm-hmm. Yeah, I think also what I mentioned before about the components. So I think it's really interesting or important to think about the components in the building that you are 3D printing and that you're addressing, because then each element is really unique, as I could show already in the 3 topics I addressed. So from our side, on the concrete side, on the structural side, we are, let's say, a bit more safe because we are printing the form, and the part that is produced is, let's say, still more close to the classic way we do concrete with reinforcement, but also for the step at the moment, it's a fiber reinforced concrete. So We still need to do testing. We still need to do extra, let's say, certification or at least proving that this is structurally valid. And I think this is also the great opportunity of now starting, let's say, combining to let's say optimize the foamworks, because this is a system that is already established, and you can still, let's say, increase and innovate within there, and then coming from the other side of concrete printing to kind of bring these things together, because I think in the end they will complement each other really well, because again there each technology is again specific for the needs. And we are now working actually on a project in Berlin where we hand in exactly this offering this service. There will be 3D printed walls, but also we will use foamwork. So it's really a process of now bringing these technologies together and combining them in the best way. And I think there we really have to go steps by steps, like also the facade that I've shown. The full polymer facade is now certified for this building, and it was a 4-story building. So in Germany, the codes, coming back to the codes again, like it's really different looking at the 4-story building or a high-rise building. For sure, the regulations for a high-rise building in this facade are very tough, and I believe it's going to be the same in Singapore as well. And that's why you really then need to see, okay, what makes sense to 3D print in order to achieve this. We have had cases also in Germany, in Frankfurt, I think in the 80s, where there were polymer facades in a high-rise tower, and we had a really severe accident. So that's why codes adapted. So codes, I mean, in my sense, in my understanding, really makes sense, because it's really the amount of experience you have and what can possibly happen. We all know the case in London, I think 4 years ago. So we have to take these into account for sure. But I'm pretty sure if then these partners all work together, finding a solution, we basically can work it out. And it's a constant development, and it needs to really exchange and see, okay, what can we do? What are the possibilities to make this product reliable in the long run? And for sure, we need testing, and we need to see how this works. That's why I'm happy to see 2-story buildings coming up now, 3D printed in concrete, really testing it out. People live in it and see how it feels, how it behaves. So this is really what we have to do, and in order to start, otherwise we don't get there, right?
We actually have another question for you, Jörg, saying, are the solutions you showed today market ready, and could you, for example, deliver 3D printed formworks today?
Yes, I mean, as I've shown, we can deliver these formworks. We're already starting to get requests, let's say, for more complex structures, which are hard to make in the traditional formwork way. And we have enough experience now with the material developments and also the latest tests that we can say we can offer this. So this is definitely possible. Which also counts for the inserts. For the facade, for sure, we're still, let's say, in the, I would say, testing mode, because it's really a new field. But also there, we're doing great progress.
Great, thank you. Let me just look through for. There's one. I'd like to find out what Witteveen+Bos's future plans for the field of construction and 3D printing in Singapore and abroad. So that's for you, Jordy.
Well, my goal is to find people who share the same vision, the same mindset, the same goals. Bring all those people together and start working on interesting applications from there. So that's something that I'm putting my current time and effort in finding those people, bringing those people together, and setting up an initiative to come to use for applications. So that's one part. At the same time, we are still working closely together on the development of 3D concrete printing for H2B. So that's another initiative. And abroad, we are especially very busy with what we call approved load-bearing structures. And that's something that I also hope to bring to Singapore. And I'm actually talking to BCA, for example, about how we can do that. We have use cases, how we have done approved load bearing structures abroad, and how can we translate that to Singapore? What needs to be adopted, what needs to be modified, what needs to be additionally tested or developed to also make it work here in Singapore. And we have several leads where we might be able to apply that in the near future. So I think that is summarized one of the plans. There's some more things that we always have in our mind that we're working on, but I think these are some key pointers.
Yeah. Actually, I'm imagining maybe, Kelvin, something BCA could think of, but when the sustainable buildings came in, we had the zero energy building built as a demonstration building. It could be very interesting to have a kind of future additive manufacturing construction, kind of like a theme park that all of us in the industry could come and experience and touch and feel these things, because no matter what you see online or even in a expo conference kind of thing, I think within the industry, it's really nice to be able to see it when it's actually relating directly to a problem you're trying to solve, at the moment.
I totally agree. We are on the same page. So yeah, we're hoping to get something going.
Great. Okay. There's one question: are the new materials more environmentally friendly compared to existing materials? I think we had different answers. Maybe we could get an opinion as to what is the most environmentally friendly additive manufacturing method in terms of recycling and circular construction.
Probably what WASP and what I forget that new other company that just announced the world's first clay 3D printed house that are using raw earth mined that's dug up on site. That's probably at this point the most sustainable one. That said, I think one of the really exciting things about 3D printing is the opportunity for new formula development. I mean, I'll fully admit where we are right now with our material, we're like an electric vehicle right now. Our upfront carbon is higher than we want it to be. But we know that, and that's part of why we've made such an aggressive commitment to being carbon neutral by 2028. It's because it really helps us drive on the development side. What does it look like to really do that hard thinking to get to that neutrality within 7 years? Because that's a short timeline. And that's why it's so great to hear companies like BASF and others that are out there that are upstream suppliers committing to significant gains over that time. And so that's something that I'm really excited about, is that shift in the supply chain across the board. And then I know Jordy and others can talk more about the concrete, but there's been some great movements in the concrete space away from Portland cement and more towards geopolymers and more towards materials that are much lower in carbon content, and also similar to what we're doing, incorporating more recycled materials, have that opportunity to bring in recycled materials as filler, as ways to add additional strength. And then, I mean, we can already recycle concrete. That's something that's out there. You can reuse it, you can grind it. I mean, we're even looking at what would it look like to use recycled ground up concrete as filler. And so there's huge opportunities for industrial symbiosis and industrial ecology in identifying, because this idea that there's such a thing as waste is really, to me, just a lack of creativity and a lack of really thinking about things in a way that address, like really looking at it as an ecosystem. Because when you, in nature, and the fact is, this is all nature, even the computers we're looking at, there is no such thing as waste, because where's it going to go? There is no way. So I think it's really also being about creative and how we think about it, and what does it look like to create those systems where we're able to take what I might not be able to do something with, but you can, and create those relationships and those partnerships so that we're creating a circular system, whether or not it's all within one company or within one location, but ideally something that we can all tap into and really amplify everyone's efforts.
Maybe I can add to this from our side, because we have for sure the advantage that as BASF Forward Dam, we are an own company, but for sure the BASF mother company is behind and the material development is there. And you see there a big, let's say, energy going towards this circular approach. I mean, looking really into how can you recycle materials differently. There are ideas of chem cycling, where you basically break the material down again, not only to producing the same material, but actually creating a feedstock for replacement for oil. So basically making oil feedstock again out of the plastics that had been used. But what is very important, what I understood so far there, is that really separating the materials to have a very clean separation of materials to be able to recycle them well, this is really the key. So that's why what I showed also in the foam works, we're working now on a coating that you can actually release later so that you can separate the materials properly. And this is a thing that really needs to be done in order to bring back the material without any, let's say, concrete residue still in, to enable this recycling process. And we have a lot of requests for sure on bio-based materials. Could you develop something in bio-based way? And at the moment, really the challenge is to have the performance compared to the normal material. And you really have to make the difference between, okay, do I create a virgin material that's based on the, let's say, traditional polymers, but then you can recycle it in a much more efficient way, because the PLA, for example, as a bio-based material, the recyclability of that material is not so easy. But sure, you can bring it back into the nature, but with certain processes that are needed. So it's a really complex field, but where we are now addressing it from different angles. And you really always have to decide then, okay, what is the most efficient material at the moment in time that works? And then for sure, proceeding there. And for concrete, definitely for cement, there are really alternatives that I hear more and more that are coming, less CO2 embedded, and also then creating the structures, as I explained, like combining it with geometries that can reduce the amount of concrete. So there are various ways of addressing this, and yeah, it takes time. I mean, it's really development. Material development is not done in a year. It's really, it takes years to do this properly, and also testing. So yeah, it's still a challenge, but I'm also very happy that the BASF is on this, because it's really a goal for everyone, and we have to work together to actually make this happen.
Great. Maybe just as a sort of final statement from each of the speakers, if you had to choose a next step, if you're in Singapore, for Singapore, if you're aware of Singapore, but if not, just sort of in general for the building industry, what would the most important next step be to facilitate this change towards additive construction? Maybe we start with Jordy.
I would say inspiration. You know, let's like Willy also mentioned. Let's start at the beginning. Let's inspire people to embrace new technologies, find the right applications for that, and work closely together with the people who can make that happen, and do that step by step. So I think there are very important small steps to make, and we need to do that all together. We cannot do that alone. I cannot do that alone, and each other party in this conversation cannot do that completely alone. So let's work together to make those small steps.
Okay, Sam.
Well, I mean, now that Kelvin's replied to in the questions that he's going to work on the code there, because the regulatory structure would be the first to me, is how do we make sure it's in the code in a way that's easy to take advantage of. And then I think, I mean, one of the things I love about Singapore is the really rich entrepreneurial and innovative environment of innovation. So I think there's huge opportunities to create partnerships between some of the universities and the amazing work that's being done there, along with the great work that the BCA is doing on the codes, and to really identify as what does it look like to build Singapore better, and what does it look like to bring those technologies in, and to Willy's point, create some demonstration projects that make it easier to say yes to the next one.
So Willy, do you want to follow in from that?
Building and construction is always a challenge in Singapore, and with the existing labor condition in Singapore, we tend to fall back on labor and easy access to labor. a good case, a good case in point is the recent deterioration in the COVID-19 in India. We stopped the inflow of workers from India, but the MOM immediately opened another source of foreign labor into Singapore. So this factor is tough to challenge. And again, like I said earlier, we just need someone to take the plunge and give this a try, and that's important. So I'm hoping to hear more from HDB, because HDB is Singapore's largest developer, and that's always an inspiration. If HDB is doing it, it means it can be done.
True. Okay. George?
Yeah, so for me also, Singapore, I always experienced as being very innovative and showing new designs, really design related, architecture-wise. In my experience, not only at One Studio, we did really nice projects there. And so I think it's really a turf where you can show what is possible. So a project that would show these possibilities that are out there that we have shown today from various sides, to really, let's say, combine this in a demonstrator project, and parallel also looking at the codes. Everything that we discussed today is equally important, the technology and bringing the codes together. So kind of making this joint project where all these things are tested and people can see it. It's really for people to see the possibilities and the new things that are out there to embrace them. So I think that would be a really cool step, would be my dream project for Singapore.
Fantastic. Okay, Mahendran, I think we're around the time.
Thank you very much.
You.
Yes. Brilliant. Thanks so much, Richard and the panelists and Kelvin. To Jordy, Sam, Willy, Jörg, all of you, was very, very enriching. I think if you ask me for that, from my perspective, what was my answer, I would say collaboration. Collaboration with the vision. And I think we're all collectively can get there. And I think we will. And that's probably the reason why we're all here together in participating in this NAMIC's virtual summit for the built environment. So all the speakers and Kelvin and Dr. Ho, please stick around till the end. We will have a photo taking together. So for our audience who have stayed on right till the end, I know it's about lunchtime now. So just have a thank you. We would like to thank you so much for being here. And we will definitely have more virtual summits and webinars up in store. So do drop a visit at our events page via the link, namic.sg events, for any general inquiries. And if you have any more questions that you want to reach out to us, to tell us, give us some feedback, etc., how we can better reach out and connect with you, marketing@namic.sg is your email address to connect us with. So goodbye, everyone. This is Mahendran Reddy on behalf of my fantastic team that has put this together. Signing out. Have a great day and have a great lunch. Bye-bye for now.